Welcome for the problem section on more on trigonometric equations, and really similar to the examples that I did during the lecture. So let's see, here we're going to come up with 2 sine theta plus sine 2 theta. Of course, we're going to use a double angle identity. So this is going to come out to, look it up in the book, sine 2 theta equals 2 sine theta cosine theta. So I'm going to put a 2 there. And then I'm going to copy this one here. So I just need to copy the theta. Well, so there we go. At this point here, factor out a sine theta. So I'll be doing that. So after I factor out sine theta, parentheses, so this one has been factored out, and I might as well factor out a 2 as well. So when I factor out a 2, of course the 2 goes here, but technically there's a 1 left, and of course when a 2 goes here, there definitely needs to be a 1 left. Okay, here we have arrived at that we can determine the solutions. Theta is going to be, well, the first one, sine theta equals 0. So that's going to be simply theta equals 0 as well as 180 degrees, and we are supposed to be in degrees, so 0 and 180. And then the other one is going to be, I'll plug that in here, 1 plus cosine theta equals 0, so cosine theta equals -1, and that of course will put us at at 180 degrees as well. So we have also here at 180 degrees, and of course one of them is doubled up. Okay. And here I guess I can write down, maybe I write that in front, and again, theta equals 180 degrees from the second factor. Okay. Next one, solve these equations. 4 sine squared plus 4 cosine minus 5. I have to get rid of one of them. Well, the sine squared, Pythagorean offers itself, so it's going to be 4 times 1 minus cosine squared. So 1 minus, let's see if I can find a nice negative there. There it is. There we go. So that's where we have substituted, and then I'm going to do the algebra, the combining here all in one big step. So factor the 2 inside, or distribute the 4 inside, so 4 minus 4 here. Then I don't need the parentheses anymore. Then I add this 4 here to the -5 over here, so -1, and then we turn around all the signs. So this one is going to be a positive, this is a negative, that's a positive. And if we're confident, we can factor that with the cosines here without going the detour of the substitution. And if I say detour of substitution, it's actually a good idea to make a substitution because it's going to look easier. But if we're confident, we can just look at this here and do it. Looks like 2 cosine x minus 1, and then the other parentheses actually looks the same, so it's going to be a perfect square trinomial. And I don't have to write that second parentheses, but instead I put a square in there. Alright, so the solutions are cosine x equals 1 over 2, so 0.5. The reference angle for that one is 60 degrees, and we're in the first quadrant as well as the fourth quadrant, so 300 degrees. And I double check that with the solutions. Oh, and then by the way, we're supposed to be in radians. So 60 degrees comes out to pi over 3. And 300 degrees comes out to 5 pi over 3. And I double check that with the solutions. And that is indeed correct. And the second one that I have here, solve this equation. Ooh, nice. What are we going to do there? Well, use the ratio identity on this one and use the reciprocal on this one and see what we get. So here we're going to get cosine x over sine x. And here we're going to get minus 1 over sine x. Then multiply everything with sine x. So let's see where that gets us. So every term multiplied with sine x, the first one, of course, will be a square. The second one, of course, we get rid of the denominator. The third one, of course, we get rid of the denominator. Ooh, not done here. Looks like more algebra. However, no big deal. Sine squared is the same as 1 minus cosine squared, so we get rid of that one. Or we use the Pythagorean theorem here. So it's going to be, substitute this one in here. There we go. Next step, we kind of just combine everything, all the terms, and again I'm going to do that in one big step, so I distribute the 2. Don't need the parentheses at this point. Add the 2 to the 1 in the back here, so it's going to be negative 1 plus 2 is positive 1. And then we turn all the signs around, so this one is going to be a positive, that's a negative, that's a negative. Let's try factoring again. Should be, of course, 2 cosine x on the first one, cosine x on the second one, and then we have a minus 1 and a plus 1 somewhere. Well, let's see which one turns out correct. Foil this backwards here, so 2 cosine times cosine is 2 cosine squared. 2 cosine minus 1 is minus 2 cosine, plus another one is a negative 1 cosine, so that's the correct one. And the last term, of course, gives us the negative 1. So we did it correctly, and the solutions come out to, and I just double check that I'm supposed to be in radians again. So x equals, the first parentheses is cosine x equals negative 1 over 2. So reference angle is 60 degrees. That's a reference angle, and it's a negative. So yeah, we're supposed to come out with a negative, so that puts us in the second quadrant and the third quadrant. So 120 and 240, and I'll convert those to radians in just a moment, and then the other one is going to come out to cosine x equals 1, which of course happens only at x equals 0, and then this one here, of course, is going to be 2/3 pi, and this one is going to be 4/3 pi. And I double check with the solutions, and that indeed is correct, except that the solutions tell me that there is no x equals 0 as the answer, and that perhaps comes from substituting in here for the sine x that we cannot divide by 0 here on this side. Let me actually go ahead and use the graphing calculator on the original one. to see that the x equals 0, to see if the x equals 0 is extraneous. Okay, so let's go over there. Okay, that's the previous one. The one that we're dealing here with is 2 sine plus cotangent, so cosine over sine minus cosecant, so 1 over sine. And then I'm supposed to be in radians. I am. And my window is, I may want to do this starting at negative pi, because I may want to look at x equals 0. And then the rest should be okay. All right. Huh, that's kind of interesting. We actually do get a solution at x equals 0. So I'll keep it, even though the book says there isn't one. So here's one at 0. Here's the other one at, let's see, pi over 6, 2, 3, 4, which is 2/3 pi. And then this one over here, apparently it's 4/3 pi, and then it happens again at 2 pi itself. I'm going to just take a screenshot of this one and insert it. There it is. So x equals 0, and actually x equals 2 pi, because the original problem had said that, no, not 2 pi itself, because it says smaller than 2 pi, so I just leave it like this here. But apparently x equals 0 is a solution. So the graph validates all three solutions. Okay. Next exercise. Give all solutions to sine plus cosine equals square root of 2. Well, let's see what we're going to do here. I think what I'm going to do is I'm going to get the cosine to the other side and then square that equation. So this is what I'm going to do. So subtract the cosine on the right-hand side. And then I square the whole thing. So square right there. Parentheses around here. There we go. Then on the right hand side, what we're going to get is, as we FOIL this, of course a 2 here. Then we're going to get a 2, minus 2 times the square root of 2 times cosine x. I like to take that square root along. Plus cosine squared of x. Cosine squared of x. Then we're still in sine squared and cosine here, so I'm going to get rid of the sine squared by using the Pythagorean. So it's going to be 1 minus cosine squared, and then the right hand side stays the same. Okay, and then I'm going to combine all the terms. So I add cosine squared to the right hand side. It's going to be a 2 right there. and then I'm going to subtract this 1 here. So it's going to be 1 right there. And now unfortunately, I have that square root in there, where presently I don't know what to do with it. Can I get rid of it somehow? Not very nicely. Let's see. Oh, I see. I should have actually, please forgive me, I should have made work a whole lot easier for me. Watch this. I take the original one, and I square the original one. So here I'm going to say the above turned out to be too complicated at this point, trying to get rid of the square root there. This actually turns into kind of a teaching moment, even though I didn't intend it to, that, hey, I try something here for a problem, and I'm kind of like hitting a wall at some point. Whoa, besides that, it's too complicated. I can't go on here, or I have to backpedal a whole lot. So let me try something else. And in fact, I'm pretty confident that the second approach will work. So I square both sides. And that, of course, square root of 2 squared is 2. And then we have a square around this one here. Okay. Then we FOIL. So here we're going to put instead. So I FOIL here, so I'm going to have sine squared plus 2 sine cosine plus cosine squared. So sine squared plus 2 sine cosine plus cosine squared equals 1. And then, of course, on the left-hand side, I recognize that I have sine squared plus cosine squared equals 1. So on the left-hand side, I'm going to have 1 plus 2 sine cosine. Now, of course, the 1 on both sides cancels, and what I have left is 2 sine cosine equals 0, and that looks a whole lot easier than what I had in my dead-end approach a while ago. As I said, this kind of turns into a teaching moment. Of course, I could have tried to edit it out. Unfortunately, that's not possible with eLive. I would have to tape myself completely over, and I'm not up for that, so I just leave it here and use it that, hey, occasionally we all come up with dead-end solutions, and we just try something else then instead. So here our solutions then come out to be, when the sign x equals 0, that of course happens at 0 itself, as well as 180 degrees, and I just have to see where I am. That is, if I'm in radians, and I guess I am in radians, so I'm at 0 and 180, respectively 0 and pi. That's for the sine. And for the cosine, I come up with 0 at 90 degrees and 270 degrees. And again, in radians, that will be pi over 2. And 3 pi over 2. Okay. And then it didn't specify what kind of interval, so I'm just going to take the entire interval. So I add to each of these here 360 times pi, 360 times k, which of course is k times 2 pi. to each of these. So that's a relatively long solution. Let's see if this is indeed correct. So I'm going to go to the graphing calculator and I graph this. Sine x plus cosine x minus square root of 2. So let's go over there. Whoops. Okay, there we go. So this one is going to be sine minus cosine minus the square root of 2. And I'm supposed to be in radians, so let's check. Yep, I am. And my window, sure, it's fine. Negative pi to pi. I don't know about the y here. That might be all right. Oh, really close to the x-axis. I don't know how to stop it. Okay, so I'm going to do only -1 to 1 graph here. And I may even want to be even closer. I'm going to do 0.5. It's just going to be easier to see. Or maybe -0.3 even, and 0.3. There we go, finally. Okay, so this one here tells me that I have a solution at 90 degrees because my scale is pi over 6, I believe. So at pi over 6, and then I have here, would be 180, and then I have 270 degrees. So apparently some of these solutions are extraneous that I got. Take a screenshot and insert it. Right there. So graphing calculator shows the following. So actually these solutions over here for the sine, they turn out to be extraneous. So I'm going to double cross these out, and actually I have to admit, above my head, I'm not sure why they're extraneous. Okay. In any case, one more problem to go, and I think I'm going to stop myself here and regain my posture and have a very short second part for this problem section. Okay, I'm back with this second part of the problem section, and in the first part, only watch the first two problems that I did there, A and B, unless in the meantime I've already typed over it and there is no C anymore. And then in any case, I did a pretty bad job with this problem C here previously and made just too many mistakes. One of them I already erased. Here's another mistake after I actually did get the the correct approach. Sine plus cosine equals square root of 2. That's the original problem. Square both sides, so fine, so good. FOIL. On the left-hand side, of course, sine squared plus 2 sine cosine plus cosine squared. And what happened on the right-hand side? How did that 2 turn into a 1? It doesn't. That's wrong. That's still a 2, which means there's a 2 here. On the left-hand side, we have a Pythagorean, sine squared plus cosine squared, which is 1. We subtract that 1 from the 2, which is a 1 here. Then what I should do is I should get rid of all of this here. And I'm definitely actually quite a ways away from the solutions. This one here is not correct either. Okay. So that one doesn't look too bad. Actually, in retrospect, doesn't look a whole lot different or easier than this one, or both of them look relatively easy. In any case, I'm not actually done with this one here. What I'm going to do next is, again, square both sides. And you will see where this leads to. So I'm going to have 4 sine squared cosine squared equals 1. And now I can use a Pythagorean right here that will get finally rid of the sine, and I only have an expression in cosines. So we're going to have 4 times 1 minus cosine squared. So 1 minus cosine squared. I'm going to use a nicer looking minus. Okay, then still not done. Now I'm going to distribute the cosine squared that's outside the parentheses. So we're going to come up here with, I'm going to do this in 2 things in one step. Oh, not that much here. So as I'm going to distribute this one here, I'm going to have cosine squared here, and here I'm going to have cosine to the 4th power. Now I'm going to take the 4 inside. So we're going to have 4 cosine squared, 4 cosine to the 4th. I don't need the parentheses. I subtract the 1 on both sides. Okay, still not done. Put this one to the front here and switch all the signs. So that's what's going to happen. So I said put this one to the front. I just like the highest power there in the front, and then switch all the signs. So there we go. And now I factor respectively. I recognize that as a perfect square trinomial that looks as follows: 2 cosine squared x minus 1. And when you FOIL this backwards, you can see that you come up with 4 cosine to the 4th power, and then the negative 4 cosine squared in the middle, and a plus 1 in the back. Okay, that means the solutions are going to come out to cosine x equals 1 over 2. Take the square root of that, which means that's square root of 2 over 2. Square root of 2 over 2. That puts us into the first and the, let's see, I want to say that's going to put us into the first quadrant, and actually into the 4th quadrant. So we're going to have x equals 45 degrees. I'm going to double check if I have to be in radians. So 45 degrees, which is pi over 4. So here we go. Pi over 4. And in the 4th quadrant, so we're going to have 7 pi over 4. And I will tell you right away that will turn out to be actually extraneous. And the reason for that is that we have squared quite a few times, and when you square, you might introduce some extraneous solutions. We will see that in just a moment. I'm going to strike this out here for now. Well, I'll strike it out later. Let's look at the graphing calculator. So here, these are solutions. Okay, go over there. And let's see. Okay. I'm going to plug in the very original one, which is sine x plus cosine x minus the square root of 2. I have to be in radians, so I'm going to double check that. My window is set to, yeah, make it 0 to 2 pi, and then this one is actually pi over 6, and then I'll see what happens to the y min and y max. And there we go. I may want to zoom in on a little bit, respectively push it down a little bit, so I'm going to do maybe -3 right here and +1 right there. Might just look a little bit better. And we can see that that 315 degrees doesn't show up. It's extraneous, and we can see that just touches here at 45 degrees or pi over 4, and then it actually will repeat at 405 degrees, so we'll add that in just a moment. Let me just calculate the 0. Let's see where we are. I have to go back here quite a bit. So let's see, right there maybe for the left bound. Oh, no, I'm too far. There's a left bound. And there's the right bound guess. 0.78, which is pi over 4. Okay, take a screenshot, copy that, and go to Word. We'll insert that, and indeed, pi over 4 is a solution, and as I said, this one here is extraneous. So I'm going to cross this out. But then here I have to say that plus k times 2 pi, those are solutions as well. Okay. One more problem. This one says, in the human body, the value of theta that makes the following expression 0, and this is the expression, r to the 4th cosecant squared minus r to the 4th cosecant times cotangent, is the angle at which an artery of radius lowercase r will branch off from a larger artery of radius uppercase r in order to minimize the energy lost due to friction. So you have the blood flow through here, and then you have a branch here, and the angle here depends on the radius of the artery as well as the radius of the branch in order to minimize the energy loss. What we're supposed to show is that this expression is 0, so that this expression here equals 0 when cosine theta equals r over 4 divided by r over 4. So we'll do that. And I believe I'm going to use the equation editor for that. This one is just to show a neat application for trigonometry. So here we're going to have r to the 4th as the original equation, r to the 4th times cosecant squared of theta minus r to the 4th cosecant theta cotangent theta equals 0. Okay. Now I'm going to take this equation and I'm going to plug in. Respectively, first I'm going to use some identities. For the cotangent here, I'm going to use cosine over sine. So I'm going to have this. Cosine over sine. There we go. And now I'm going to use that condition that we had earlier when cosine theta equals r to the fourth over r to the fourth to substitute in here for the cosine. So I'm going to substitute that in times r over 4 divided by r over 4. And of course, we have substituted in for the cosine. At this point here, even though this looks quite complicated, I'm actually virtually done. Watch what happens. Of course, this r to the fourth here cancels with this r to the fourth. So I simply have an r to the fourth right here. This 1 over sine here is the same as cosecant, so I actually have a cosecant squared right there. And then I can look at this one, I can look at this one, and I see that the two are identical, and being subtracted from each other comes out to 0, so that statement is true. Then we're supposed to plug in some numbers. It says find the angle theta when we plug in the radius 2 millimeters and radius 4 millimeters. And I'm just going to use this one here, where I plug in 2 millimeters right there and 4 millimeters right there. And then we're going to come up with cosine theta equals 2 to the fourth power divided by 4 to the fourth power. Comes out to a nice 1 over 16. 1 over 16, and then of course we take the inverse cosine of that, and I do that on the side, and I'm going to come up with, change my calculator to degrees, inverse cosine of 1 over 16 is 86.4 degrees, and with that one we're done with this problem section. More on trigonometric equations.